let's discuss about Hooke's law. Okay, now Hooke's law is one of the most important derivations what you have in this particular chapter, and also Hooke's law is quite important. Now I'm talking about in practical perspective. Alright, now let's talk about what is Hooke's law. The definition of Hooke's law is quite simple, but before that, let's try to understand what is that. Now assume that you have a spring. Okay, now at the end of the spring, let's say you are going to add some weight. Okay, maybe like 2 grams, something like this. When you add the weight, the spring is going to extend, correct? Let's say you add one more weight to it. Maybe instead of 2 grams, you added another 2 grams. It's going to become 4 grams. The extension is going to be even more, correct? Now, in simple words, in layman terms, the more load you apply, more is going to be the extension of the spring, correct? Now, this is basically Hooke's law. Now, what Robert Hooke, what he told was that the more load you apply to any body, then more is going to be the extension. But generally, we talk about spring. Alright? Now, let's come to the formal definition of what is Hooke's law. Alright? Now, the definition is, it states that the extension produced in the wire is directly proportional to the load applied within the elastic limit. Okay, now within the elastic limit is quite an important word. The reason is, if it goes beyond the elastic limit, then the wire will be stretched so much, or the spring is going to be stretched so much that it cannot come back to its original position. Okay, there is something called as elastic limit. This is the mathematical, not mathematical, it's more like definition of Hooke's law. Now let's look at how we can represent it. See, you can have extension is proportional to the load applied, correct? More load you apply, more is the extension. Quite obvious, isn't it? The next part what you have will talk the same thing in terms of stress and strain. See, when you apply certain load, stress is applied on the body, correct? And if there is stress, then obviously strain will also be developed in the body, correct? Now what you can tell mathematically is that stress produced in the body is directly proportional to the strain in the body. Alright, now this can also be the definition of Hooke's law. Though mathematically if you have to write, then what you can write? Stress is directly proportional to strain. Alright? Now when you have to remove the proportionality, you have to introduce a constant. Stress is equal to K into strain. Now this K is called as modulus of rigidity. Okay, now what it is and everything you guys will learn later on. But K is the constant of proportionality. Alright? Now in the beginning I gave you the example of the spring and the load, correct? Now, if we plot it across a graph, this is how the graph will look like. Okay, you have the load, you have the extension, and see, this is how it's going to be plotted. Alright, you are going to get a straight line passing through origin. Now, this has quite a importance, especially passing through the origin part. In the sense, if no load is applied, there is no extension whatsoever. And more load you are going to apply, more is going to be the extension. Alright, now this is Hooke's law. So, okay, again, let's just to recap quickly. Whatever load you are applying on the body, and the body in the sense for a wire or a spring or whatever you have, within the elastic limit, that extension is proportional to the load applied. More the load you apply, more is going to be the extension. Alright, this is Hooke's law.